This allows you to paint that area underneath. You don't want to use a foam roller. So standing here we've got about 40, 45.
As a matter of fact, 95% of those circuit counter switches installed without consultation are installed incorrectly and there's no benefit.
Hello, welcome. Just going to do a little rundown on the EM Field Probe, one of the instruments from the GeoVital Academy. Just to quickly compare it with its brother, the HF Field Probe, the EM Field Probe is a little bit shorter. The EM Field Probe can come delivered to you with a carry case. This keeps these two units nicely together and stores your equipment nice and safe, and is also great for traveling with. The unit itself comes delivered with a charger and a charger cable. This charger cable may be behind the foam that's in the lid. So if you're missing it, let's have a look there as well. Now the charger functions in both 110, 120 as well as 220, 240 volts countries. So you're okay to use that there. It has a European plug on this end. Depending on where you are, we may have been able to supply you with a travel adapter. This travel adapter has the European PowerPoint outlet, and you can plug your charger in there to then charge with. Now this cable uses a USB connection. There's no movement of data, it's just to charge with, and this goes into the unit. Now you'd be forgiven for thinking, well, hey, hang on, isn't this handy? This is a USB cable. I could plug this into the USB charger I have in the car or from a cell phone and charge the EM Field Probe using those chargers. I have to warn you against this, and I can't make that clear enough. The unit itself has a fuse built into it. If you use a charger that puts too much charge in, too much electricity comes in, the fuse will pop, the fuse will go to protect the insides of the instrument. When that happens, your instrument will have to be sent back to Austria for repair, and so you're going to be without your instrument for a while. So I can't stress it hard enough that please only charge this device with the supplied charger. Now to charge it, there's like a data port down the bottom, again used for the charging. This cable just nicely goes in there, and you activate the PowerPoint, the outlet, and charge your unit. When it's charging, an animation will come on the display. It'll show a battery going from full slowly to empty, going from empty slowly to full, and also a countdown of 180 minutes, and then counts down. This is just an animation. It is not related to how full the battery actually is. So don't be discouraged that when you've charged it and you take the power off and let's say you put the power back on, that the animation starts over again and starts showing you an empty battery. 180 minutes is a decent time to charge it, but you can also leave it overnight. There's no problem with that. Okay, now the unit is available with the electric field antenna, which is flexible, goes in the top, and it can also come with a magnetic field probe. When you activate the unit, you just press the big button on the front. It only has 3 buttons. It can be much simpler. It always starts up in default for electric fields because this instrument's claim to fame, and it expresses that in volts per meters. It is an easy to understand display which the professional as well as the layperson can understand. We even put a little man on there who's indifferent to the situation when the levels are low, and he gets unhappy when the levels start getting a bit higher. Also the bar graph fills up from green, yellow to red, and so obviously that's easy to understand for everybody. One of the things that makes this instrument so unique is that the antenna is on the outside of the instrument. Normally with electric field meters they're on the inside, here it's on the outside. This gives us the ability to touch objects and also touch people. The way we contact surfaces, as in walls, but specifically the body these levels, these volts per meter levels get inflated. If we took a measurement of the air for electric fields, the levels would be far lower in the same environment. This is okay though. The levels that we're chasing, that we want to try and get the environment under, are also much higher than in comparison value if you were measuring the air. So in the end, no matter if you use this measurement or an instrument that measures the air or a body voltage meter, you eventually come to the same answers in terms of which electrical circuits are causing this electric field exposure. Now, because we designed this and we also designed it with our consultants in mind, we did a few handy things that help with the assessment process. When the counter, the figure is under 30, there's no sound. Above 30, a Geiger counter sound starts kicking in. Then we get a tuck, 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 and it gets quicker and quicker. When you get to 100, an alarm gets put over the top of it. A beep, beep, beep gets put over the top. Now, this beep, beep, beep alarm can be deactivated. The Geiger counter sound cannot be deactivated. To turn off the alarm, you press the middle button, a little speaker icon, a little stripe through it. To turn off or turn on the beep, beep alarm put over the top once it passes 100. The Geiger counter sound can be turned off, as I mentioned. So if you're mid-measurement or mid-assessment and you want to talk about this, let's say, the volume, the sound comes out of the little hole at the back. So if you just slide your finger onto the little hole at the back, then the sound is very dampened. So if I just show on the wall behind me, at the moment I've got a nice low reading on here, but as I get near the wall, the number starts rising. When I go past 30, we get the Geiger counter sound. This is 60, sorry, about 80, 90, and as soon as I go past 100, we get that alarm, the beep, beep, beep coming over the top. Where this is helpful is that if somebody is taking the assessment and seeing what values you get, and the other person is at the circuit breaker panel doing some testing, which our consultants can do with you, then the sound can give an indication at quite a distance of what goes on. If there's no sound, the level is nice and low, it's under 30. If the level goes higher and passes 100, we hear the beep, beep, beep being put on top, and so we already know when a word being said that that level is higher than 100, which helps in the assessment process. Okay, with this instrument to take a measurement of, for example, the wall, we hold the instrument firmly. We can already see that we're exposed to an electric field from the wall that we're standing near, and as we get closer, of course, that value is going to go up. When we pass the 30, the Geiger counter sound starts, and when we want to measure that wall, we don't actually just touch it with the tip, we actually have to flatten the antenna against the wall with about a 45-degree angle between the instrument and the antenna. So just like this. If somebody's helping you take measurements, especially when circuits are turned off and you're having low readings, make sure that people don't kind of rub the antenna against the wall. This could cause friction. It's a very sensitive instrument and that'll give you a spike in the reading. So just always try and hold it as still as you can. Okay, there's a battery indicator in the top left corner, so you can keep an eye on your battery charge. You get quite a decent time of assessing out of it, and it's a good idea to charge the unit when you're finished, so it's nice and full for your next go. To investigate magnetic fields, you'd need the magnetic field probe, which is this one. You would have to change the measurement value from volts per meters to nanoteslas by pressing the little signal icon on the far right here. Now it changes to nanoteslas. And insert the probe. Now this probe measures on one axis only. This is kind of an old way of doing it, and we made it like this because we had a lot of old consultants who used older devices and they wanted something very similar. So this only measures on one particular axis. What that means is when you want to investigate magnetic fields, you have to go through the routine of measuring all three axes and then applying a mathematical formula to figure out what the actual value is. So you would measure one axis, note the number, the other axis, note the number, and the other axis, and note the number. There is a shortcut, which a lot of people use, is that you use the highest value you find, half of the second highest value, add them together, and then you get a bit of a shortcut, rough idea, relatively close of what that official formula would have given you. That's what most people do. Or you just pan it around and rotate and look for the location that gives you the highest reading, and then that is obviously your reading. Electric field assessing is more is claimed to fame for this instrument, so make sure you put it back to volts per meter. Now it's very important to realize with the electric field assessment that this instrument measures a difference between surfaces. What that means, for example, if I'm standing on a floor, as I am now, and I am measuring a wall, let's say that I'm getting 400 from the wall and I'm getting 300 from the floor, this instrument is going to show me the difference. So the instrument will show me 100. If there was nothing on the floor, and I measure the wall that's got 400 on it, it would show me 400. So the best way to assess is to compare what it is you're touching with 0. Now where you're standing is most likely not 0. So that's why the instrument is supplied with a grounding cable. This grounding cable has a contact pin on one side and an alligator clip on the other. Now if you live in Europe and you have your normal power point and you have these metal bits exposed, these metal bits are ground. That's how your plug connects to ground and make your equipment safer to use. So it's very convenient if you've got this all throughout the house, is that you've got these little metal bits that you can easily get access to contact ground. So you can use this alligator clip, plug it on there, and now this cable is grounded. If I now insert this pin in the bottom of the instrument, or I hold on to the pin with my fingers, in which case I'm grounded, I can now also measure and compare, what that or see what that level truly is compared to 0. Okay, now if you have a travel adapter that came with your kit, if we were able to send you one, or if you're looking to purchase one, you're looking for a travel adapter that has that full European design. There's a lot of cheap travel adapters that kind of fit all these different models of different countries together. You kind of need one that gives you the full European design, including those metal bits. And in that case, you can put this into your outlet or your power points in the house that you're assessing. And so now in the travel adapter, you can also connect to ground. And so it's again easy to work with. Okay, so ideally we found it's easiest to hold on to this pin with your fingers. So just hold on to the ground yourself and then measure what it is you're interested in measuring. So normally in a bedroom scenario, you would ideally have somebody in the bed and measure their foot grounded. Now in many homes you don't get much electric fields from the floor, so you're kind of engaging the surfaces of this wire really unnecessarily. So sometimes you try it without the cable first. If you get a relatively low reading, then you want to grab that cable and just to compare to make sure that that is the reading that you're really looking at. Right, so in theory, what could happen if I'm, for example, in a room that's shielded and I've got shielding paint on the wall and this wall is grounded and I'm standing on a floor that has electric fields on it, I could touch the wall, but even though the wall is 0 because it's grounded, because I'm getting electric fields, I'll get a reading on the instrument. And you might think, hey, hang on, something wrong with that wall, I've got electric fields on there. No, the electric field, the electricity can go both directions. It can go from what you're putting the antenna on down through you, or it can go the other way. So yeah, you have to be conscious of that.
Okay, und das sollte nicht sein. So, jetzt ist die Frage, warum? Warum macht es das?
Hallo, grüß Gott.
Hallo.
Hallo, Herr Hahnen.
Okay, also hier haben wir das Thema, wir haben Strom auf dem Boden.
You can't measure the surface you're standing on unless you're grounded, right? If I touch measure the ground like this, I'm measuring the same surface that I'm standing on, so I get a very low or no reading. So again, if I ground myself and then measure the floor, then it will reveal to me if there's electric fields there.
Wenn ich jetzt auf dem Boden stehe und halte das Messgerät hin, kann ich das nicht messen, weil ich die gleiche Spannung habe wie das Messgerät selber. Ja, in dem Moment muss ich mich jetzt aberden und das mache ich dann, indem dass ich jetzt zum Beispiel hier hingreife. Ja, und dann geht ja schon los. Ich kann auch hier an den Erdungsdraht hingreifen. Ja.
So in an assessment, normally what we do, we're really interested in the bedroom, and that's where this instrument comes to its own. So you'd ask somebody to lie in the bed. You'd ask them to take, decorative pillows and that sort of stuff away so they can put their head where it would normally be as they're sleeping. And then you want to basically not actually stand so close to them, as in you don't want to stand next to them. So you're in the way of some electric fields that may be normally getting to them at night. So it's best to stand at the bed head, the feet end of the bed. Ask them to take their sock off, and you place this antenna gently between the toes. And you just rest it there gently, and then you get that reading. Most homes, probably 95%, will be inundated with electric fields, and it's something that influences our sleep. An investigation is then necessary to figure out which circuits are responsible for this. This is where one of our consultants could assist you, and so contact one of our academies around the world to find out which consultant is closest to you, and we can help you. We also have workshops where we teach you how to investigate homes, also using this instrument. So that's something that kind of goes beyond the scope of this video to show you.
Now, in those two, low frequency, we have magnetic fields and we have electric fields. They behave a little bit differently. We touched about this briefly yesterday.
14. Yeah? Simon, and you go and put your hand on the Fensterladen. Okay. So now it's going up to 80. Yeah. Just break it. Now we are down to 33. Yeah. If you put the hand together, it's going up to 80. If I'm coming closer, with the antenna, we have 130 already. Yeah, Martin. 170. Yeah, as closer I come, as higher the level width, because everybody is grounding a little bit by itself. No? Yeah. So it's getting less. But anyway, even if you have, let's say 8 or 10 or 15 people, yeah, you still can measure it at the end. And it's the point how good a human body conducts. Genau.
So remember to charge your device after you're finished using it, so it's always nice and full for when you need it. The battery has been specially designed for this unit. It gets its fullest charged, or its full capacity, after having been discharged and fully charged 5 times. So if you do that, as you get the unit new, it's good for the battery, and you get a lot of longer spans of use out of it. Excellent. So I hope this was helpful, and if you've got any questions, then of course please contact your supplier or the academy. Thank you.